ends of 3, so to have 3, 5, 4, 4, 4, right?
Mm-hmm.
Probability PQ is what? 4, 4, 4, right?
Mm-hmm.
What's the total number of cases?
Cases to like distribute 20 balls among 5 bins.
Yes.
Doesn't tell you if the bins and balls are distinguishable or not.
Because they are objects, they are distinct. Okay. They are real objects. Okay.
Okay.
When we have real objects, usually they are distinct, except the case that it says, okay, consider them as same objects. Okay.
Mm-hmm.
For example, let me tell you something. This is a famous question of that. Suppose we have 2 coins, okay?
Mm-hmm.
What's the probability? Each coin is H or T. What's the probability to have 1 H?
Like exactly
Or
1
let
H.
me tell you what's the probability of, what are all the cases? Or what's the probability to CTT?
1/4.
Oh, yes, you say 1/4 and 1/4 is correct. But someone, if we consider same objects, then we have HH, HT, TH, TH, and HT are different, okay? And as you did this, 1/4, because you consider 4 different cases. These 2 cases are not similar, right?
Mm-hmm.
Even if the problem doesn't say that the coins are different, you should consider all of them are different, okay?
Mm-hmm.
But sometimes, for example, the problem determined that all the cases, we consider these 3 as all the cases. Then it would be 1/3, right?
Mm-hmm.
If the problem says. But in general, you should consider them different. Here, we have the same thing. You should consider all the balls and all the beans are different. Right.
Okay. So would it be 5 to the 20th power?
Exactly. 5 to the 20.
Okay.
Now, for P number of cases, calculate. Q is easier. Let's just start with Q. What's the number of cases for Q? Number of cases.
Um, so would it be 20 choose 4 times 16 choose 4 times 12 choose 4 times 8 choose 4 times 4 choose 4?
So when you say 20 choose 4, you say, okay, which 4 balls are together, right?
Mm-hmm.
But do we determine that they go to which bin or not?
So if you have wait, the first one choose 4 out of 20. Then would you then have to multiply by 5 to the 5?
No, you shouldn't multiply by anything, and it is correct. Do you know why?
Because order doesn't matter, I think.
No. Let me tell you something that is so much important. This part, let me tell you a point. There are 4 students, okay?
Okay.
You want to split them part A to 2 parts. A group with 1 member, a group with 3 members. How many ways are there?
4.
Exactly. To split into 2 groups. What about this case? 2 group, each has 2 members. for these two groups. How many ways are there?
3 ways, I think.
Yes, why 3?
Because if let's say student A has to be paired with someone, either B, C, or D, and then no matter who you pair student A with, that group with student A will be full, and then the other group will just already be decided because the other 2 students will go into the second
Yes,
group.
because the groups have same number of students, we can permute them. For example, here we don't have any permutation, but here A, B, C, D, A, C, B, D. If you say 4, choose 2, A, B, A, C, A, D, B, C, B, D, C, D. Then A, D, B, C, B, C, A, D, B, D, C, A, C, and this one A, B. So these 2 are the same, these 2 are the same, these 2 are the same, right?
Mm-hmm.
So it would be 3. But if, for example, the first one is team 1, team 2, you shouldn't divide by 2, right? If they have the names. Here we have the same thing. If we didn't, if the beans didn't have name, we should divide it by what?
Divided by 5 factorial.
Exactly. If, for example, it says split 20 students into 5 groups, each has 4 members, then we should divide. But here, because the beans, for example, we have bean 1, B2, bean 3, we shouldn't divide. Okay?
Mm-hmm.
Agreed.
Mm-hmm.
Okay. Now, number of good kids. Wanna try the rest on your own?
Okay. So I got something like 576 over 720, and but the problem is even after simplifying, that still isn't correct.
Okay, let's see. What's the number of good cases for P?
20 choose 3 times 17 choose 5 times 12 choose 4 times 8 choose 4 times 4 choose 4.
Look, when you say 20 choose 3, you should determine these 3 students that you selected go to which wing.
So should it times 5?
Mm-hmm. Do you need another hint or is that enough?
I think that should be enough.
Okay.
Times 5 times 4. 180. Make this 36, and then 36, 576 minus 36, 121. So is it 16? So E?
Okay. Explain P.
Uh, oh, God. So 20 choose 3, and then 16 choose, oh, no, not 16, 17 choose 5. And then times 4, because you need to choose one of the 4 remaining bins. And then 12 choose 4 times 8 choose 4 times 4 choose 4.
Yes, here we have again 3, 2, 1, but at the end we should divide by 3 factorial, so it would be this, right?
Mm-hmm.
Okay. Do you agree total number of cases is not important since we divide P by Q? Agreed.
And then, and then we should also be able to cancel the 12 choose 4, 8 choose 4, 4 choose 4.
You divided this. Okay, so we can use this one, or 12 choose 4. 20 choose 4, 16 choose 4, divided by 20 choose 3 times 5 times 17 choose 5 times 4, right?
Mm-hmm.
Okay, so 20 factorial over 4 factorial, 4 factorial, 12 factorial, right?
Mm-hmm.
And 20 factorial, 3 factorial, 5 factorial, 12 factorial times 4, 5, right?
Mm-hmm.
We can cancel 20 factorial.
And 12
Then,
factorial as well.
yes, 5 factorial here, 5 is left. Here 4 is left, right?
And
So
then
it will be 5 over. We
5
can cancel
over
also
4
this
times
5 with
4
this
times
5.
5.
Hmm?
Okay. So then it would be 1 over 16. Oh, wait, no. That was Q over P that we just calculated, not P over
That
Q.
should
So it should be 16.
be
Because
divided.
22
Yes, Q
Q.
over P is this. Yeah, so P over Q is 6. Exactly.